Hello, guys. Welcome back for the series of engineering mathematics. So, in the last lecture, we did successive derivative. So, our today's topic is Leibniz theorem. Leibniz theorem. Now, see, guys, what is Leibniz theorem? Now, see, we know that suppose if we are differentiating product of two functions like this, we know that we apply product rule like this: du by dx into v plus v into sorry it's u into dv by dx. Now the question is, since we are finding the first derivative, suppose we want to find nth derivative of the product of two functions. So the Leibniz theorem is stating something like that. See, it behaves like this. You will write this way: nc0. First you write nc0 brackets, then nc1, then these brackets, then nc2, then these brackets, and till ncn, and again write these brackets. Now what symbols we are using here? U and V. So what you will do here? Put these symbols U and V here. U, V, U, V, U, V, U, V. Now see what we are going to do here. I'm putting here V0 and here is N. Guys, just try to understand that V0 means the only function and Un means dn of, that is nth derivative of u. And please try to maintain this pattern in such a way that the sum of the subscript is n. Now what will happen? This u will go from its maximum to minimum, and its minimum is 0. And this v will go from its minimum to maximum n. So term by term, what will happen? It will be n minus 1. It is v1. It is n minus 2. It is v2. So at last, it will be at u0 and it will be vn. So I hope you understand the pattern. Now try to understand that v1 means the first derivative, that is dv by dx. And v2 means its double derivative. And v3 means its third derivative, like this. So this is the pattern, guys. Now, how we are going to apply this thing to the problem? Now, the first problem comes here. Problem number 1. Suppose we have y is equals to sine inverse x over root 1 minus x square. And the question is, prove that 1 minus x square into yn plus 1 minus 2n plus 1 into x times of yn minus n square of yn minus 1 equals to 0. Now guys, in order to find the solution of such problems, the first thing is you develop a relation here first. You have to develop first an relation. Now, how we are going to develop such a relation? Now see. Okay, now can we write this? Solution is something like this. Can we write this as y, just switch over the terms, just shifting this way. Now differentiating with respect to x. Now what will happen? Now here on the left hand side, we are going to apply product rule. It's y1 over root 1 minus x square plus y over 2 over root 1 minus x square and into minus 2x by chain rule, and its derivative on the right hand side is root 1 minus x square. Now let us take the LCM. If I take the LCM, it is y1 into 1 minus x square minus xy over root 1 minus x square equals to 1 over root 1 minus x square. Now this will get cancelled. Of course, this cannot be 0. So we have y1 into 1 minus x square minus xy equals to 1. Now this is the first thing that you have to develop such a recurrence relation. Now since we want to establish that relation, now just recall the Leibniz theorem. That is, in short, I'm calling it as LT theorem. LT. What was the scenario? It is something like this: NC0, UN, V0, NC1, UN minus 1, V1, and goes like this. Now, I'm taking this as my star. Now, differentiating star n times by using Leibniz theorem. Please, whenever you are opting u and v, always opt v such a function such that its derivative vanishes after finite number of steps. Suppose I am considering this part, y1 into 1 minus x square. If I am taking this as my u and this as my v, what is going to happen? I will write nc0. Now see, y1 is already differentiated, so y is already differentiated 1 times. So if I differentiate it n times, so it is nothing but yn plus 1. And my v0 means the function as it is. Now use the pattern. nc1, it is yn and its first derivative is minus 2x. Then nc2 yn minus 1 into minus 2. Now the next term will be 0 because the derivative of the constant is 0, and so on. Now please guys try to understand that what is NCR. NCR is n factorial over n minus r factorial over r factorial. I'm giving you the shortcut that how to get rid of this calculation. NCA is equal to NCB. This is come true if and only if either A is equal to B or A plus B is equals to N. So please try to understand that NC0 is 1, NC1 is 1, sorry, NC1 is N, and NC2 is N into N minus 1 over factorial 2. Just try to understand the pattern. NC3 is N minus 1, N minus 2 over 3 factorial. Now let us apply this. If I apply here, now see what the calculation will become. It is NC0 is 1, so it is yn plus 1 into 1 minus x square. NC1 is n, so it is minus 2 times of nx into yn, and this is nothing but n over n minus 1 over 2 into minus 2. So you can easily see that the calculation of this term is like this. Now if I do it collectively, now again if I do the n derivative of x o into y. Now if I will take this as my v and this as my u, so it is nothing but nc0 v as it is, and it is yn nc1, and the derivative of x is 1 into yn minus 1. So it is nothing but x times of yn plus n times of yn minus 1. Now please substitute these terms. in the main relation over here. Now, after differentiating, it will become like this: yn plus 1, 1 minus x square minus 2nx yn plus, since minus sign was there, so minus n into n minus 1 into yn minus 1, and since minus times is there, so minus times of this is xyn plus nyn minus 1 equals to 0, because derivative of 1 is 0. Now let us rearrange the terms accordingly. 1 minus x square into yn plus 1 minus 2nxyn, and it is nothing but minus n square yn minus 1 plus nyn minus 1 minus xyn minus nyn minus 1. This will get cancelled. Now if I merge these two terms together, now it is turning out to be 1 minus x square yn plus 1 minus 2n plus 1 of xyn and minus n square yn minus 1 equals to 0. So guys, look at the same thing we want to prove here. So we establish the proof of the same. Now we have another question based on this Leibniz theorem. Now see how we are going to deal that question. The question is problem number 2. The question is something like that: if log y is equals to tan inverse x, the question is show that 1 plus x square yn plus 2 plus 2 times of n plus 1 of x minus 1 whole of this bracket yn plus 1 plus n into n plus 1 of yn. Guys, I'm just sharing one trick. First, what you will do here, put n equal to 0. Put n equal to 0. So you have to establish some relation, something like this: y2 and then something like this, some bracket, then y1 and so on. This type of relation you have to establish first. So now how to get rid of that? The solution something like this. Since its log y is here ln, log y is same as ln, that is base is e. So we can switch over this as y is equal to e raised to power tan inverse x. Now let us differentiate it. So y1 is e tan inverse x over 1 plus x square. Now shifting the term. Now what is this? This is nothing but over y. Now again differentiating it. Differentiating again with respect to x. Now what is going to happen? Apply product rule, y2 1 plus x square, and derivative of 1 plus x square is 2x y1, and again what you will observe here, it is nothing but y1. So we have y2 into 1 plus x square plus 2x minus 1 into y1. Now this relation we have obtained from here. Now try to understand it, how we are going to establish the relation. Now let it be 1. Now differentiating 1 n times by using Leibniz theorem. Now guys, when I apply the Leibniz theorem, just try to understand that how I will take u and v. I told you that always take v as that function whose derivative vanishes after finite number of steps. This is my u. Here again, this is my v and this is my u. Now let us apply in the first part. nc0, 1 plus x square as it is, and this is yn plus 2 because it's already differentiated twice. Again, if I'm differentiating it n times, so how many derivative we have taken? N plus 2. Now, next step will be nc1, and then the derivative of this is 2x yn plus 1, nc2, and the derivative of 2x is 2 into yn. Then there will won't be any term because the next term will be 0 because derivative of the constant is 0. Now switch over to this. nc0 yn plus 1 into 2x minus 1 nc1. Now the derivative of 2x minus 1 is 2 into yn equals to 0. Now let us rearrange these terms. This is 1 plus x square into yn plus 2. Now nc1 is n. This is nothing but 2nx yn plus 1. nc2 is n into n minus 1 over 2 into 2 times of yn. This 2 will get cancelled over here. Again nc0 is 1. Now try to understand this nc1 is nothing but n, so 2n yn. Now what we are going to do, I will rearrange the terms accordingly. Now see this term and this term, if I take yn plus 1 as common, so I will be having 2nx plus 2x minus 1, and now we have this can be written as these two terms. If I multiply and simultaneously n square yn minus n yn plus 2n yn equals to 0. Now I can further write this as 1 plus x square yn plus 2. Okay, now if I take twice common here, n plus 1, and this is n square yn plus n yn. Now this is again 1 plus x square yn plus 2. Keep trying, and you will reach to the conclusion. Now what can I write these two terms together? If I take yn common, n square, then again if I take n common, then it is n plus 1. The same thing we want to establish, guys, so hence proved. So this is the thing we want to prove. I hope, guys, it looks easy and okay trick. Easily we have established it. You can easily see we have established what exactly we want to establish here. See, we have done. All right, now let us consider one more problem so that you can feel the concept. It's not so difficult at all. The only thing is that how to apply this concept. Now we have another problem. Okay, the problem is something like this. If y is equals to cosine of m sine inverse x, the question is prove that 1 minus x square into yn plus 2 minus 2n plus 1 of x yn plus 1 plus m square minus n square into yn equals to 0. Now see, again the first thing is that establish some relation, something like the bracket into y2 plus bracket into y1, or maybe some y. This type of relation is necessary. Now solution something like this. Let us understand it. Let it be 1. So differentiating 1 with respect to x. Now what you are going to obtain? y1 as minus sine m sine inverse x. Now apply chain rule, m over root 1 minus x square. Now switch over the terms. This is minus m times of sine m sine inverse x. Now what I will do, squaring both sides. Squaring both sides, I will be getting y1 square into 1 minus x square, that is m square sine square m sine inverse x. I can write this as m square. My target is to again get back to y, so I can always write this as 1 minus cos square of m sine inverse x. Now what is this term? 1 minus y square. Now again differentiating again with respect to x. Now what I will do, apply a product rule. This is 2y1 into y2, 1 minus x square minus 2x into y1 square. Now see, this term is nothing but m square minus m square y square. If I differentiated, m square derivative is 0. This is minus 2m square y into y1. Now without loss of generality, y1 cannot be 0, so we can cancel it. And moreover, this 2 will also get cancelled. So I will be getting y2 into 1 minus x square minus xy1 plus m square y equals to 0. This is my target. This was my target, in fact, initially, to make such relation. Now differentiating 2 with respect to x n times by using Leibniz theorem. Now I will take this as my v and this as my u. Again, this is my v, this is my u. Since it is a constant, so we can use it directly. So nc0 yn plus 2 1 minus x square plus nc1 yn plus 1 minus 2x plus nc2 yn into minus 2. Now next term will be 0. Now since minus sign over there, so I'm putting bracket here, nc0 yn plus 1 into x plus nc1 into yn plus m square yn. Now it's a time for simplification. Okay, I am changing the color, so it is 1 minus x square yn plus 2 plus, now this is, since minus sign is there, so I can write, because nc1 is n, so it is turning out to be 2 nx yn plus 1. nc2 is n into n minus 1 over 2 into yn into minus 2, so this will get cancelled. nc0 is 1, so minus x yn plus 1. nc1 is n, so minus n yn plus m square yn. Now see, can we merge these two terms together? Yes, of course we can. This is yn plus 2, so minus 2n plus 1 into x times of yn plus 1. Now let us simplify it. Minus sign is there, so minus n square yn plus nyn minus nyn plus m square yn. Now this will get cancelled. Now again rearrange the terms. 1 minus x square yn plus 2 minus 2n plus 1 x yn plus 1. So I can write this as m square minus n square into yn. Now guys, this is the thing we want to establish, so hence proved. So I hope guys you must have understood all the concept that we have discussed in the today's lecture. So slow and study wins the race. So I'm not solving too many problems in one lecture. So wait for my next lecture. So we'll solve more problems on Leibniz theorem. So till then, bye everyone. So please support us or support me for subscribing my channel. So consider it. Thank you everyone for watching.